A pleasant day to all of us. We are the group 3. I am Desiree Martinez.
I am Jollibee Sirot.
Jaquilyn Calledo.
I am Aljun.
I am Angelo Gitalan.
I am Axl Heart.
And today we will be presenting our project with the concept LED chaser with chip register using Arduino. Let's go!
The 7 LED light bulbs light up one after another until it reaches the last light bulb, then onto the buzzer. This will repeat for all the LEDs in a loop, where the next LED will light after another until it reaches the end. We'll use a shift register to give you control over an additional 8 outputs. In this, we can control the output of the shift register to the LEDs with the Arduino Uno, which has code embedded to it, which we will show later. In this project, we need these components.
First, breadboard.
Next, an active buzzer.
Next, 8 220 resistor.
Next, 7 LED bulbs with preferred colors.
Next, 16 wire links.
Next, we have 13 jumping wires.
Next, the 74HC595N. And lastly, let us not forget our Arduino Uno as our microcontroller board, which will be powered by a USB 2 cable later on. First, we will place our 74HC595 or shift register facing this way, and we can insert jumper wires and wire links to each of its designated pins later on.
Okay, let's move on to the second component, which is the wire link. So, first wire link will insert from positive power rail to pin 16 of shift register. Then, the other wire link will insert from negative power rail to pin 13 of shift register. Next, wire link will insert to positive power rail to pin 10. Next, the wire link will insert from negative power rail to pin 8. Then, follow the rest as is. Third component is the resistor. The first resistor is in line with B15 to F15. Okay, the next resistor is in line with B17 to F17. Then, the next resistor is in line with B19 to F19. The next resistor is in line with B21 to F21. The next resistor is in line with B23 to F23. And the next resistor is in line with B25 to F25. The next resistor is in line with B27 to F27. And the last resistor is in line with B29 to F29.
Next, for the fourth component, which is the LED, the anode is the longest pin and the cathode is the short pin. We need to inline the anode with the resistor and the cathode in line with ground wire link.
So, the fifth component is the jumper wire. Insert the jumper wire from pin 1 to 7th resistor, pin 2 to 6th resistor, pin 3 to 5th resistor, pin 4 to 4th resistor, pin 5 to 3rd resistor, pin 6 to 2nd resistor, pin 7 to 1st resistor.
For the sixth component, which is the active buzzer, all we need to do is we need to inline the anode with the resistor and the cathode inline with the ground wire link.
Insert the jumper wire from pin 11 to pin 6 Arduino, pin 12 to pin 5 Arduino, pin 14 to pin 4 Arduino. Insert the jumper wire from positive rail to 5 volts Arduino. Then, insert the jumper wire from negative rail to ground Arduino. The 595, also called as the shift register, essentially controls 8 separate output pins using only 3 input pins, controlling how the LEDs light up, and with a little bit of coding, the LEDs turn off after it ends and starts over like a loop. This will repeat for all the LEDs in a loop, where LEDs will light after each other until it reaches the end, which is the buzzer. The 74HC595 or shift register will distribute its output accordingly to its embedded code. We can also set the delay or even do a reverse with a little tweaking of the code. The 7 LED light bulbs light up one after another until it reaches the last light bulb, then onto the buzzer. This will repeat for all the LEDs in a loop, where the next LED will light after another until it reaches the end. We use a shift register to give you control over an additional 8 outputs. In this, we can control the output of the shift register to the LEDs with the Arduino Uno, which has code embedded